Every 22 minutes, a signal strikes the Earth. It has been repeating, without fail, for 37 years. And according to the laws of physics, the object sending it should not be able to exist. Tonight, the impossible lighthouse, hiding in our own galaxy, and why it breaks the rules of dead stars. And why its signal was hiding in recordings we made decades ago, and no one ever noticed. The Australian outback. No cities, no noise, just hundreds of spider-like antennas listening to the sky. This is the Murchison Widefield Array, a radio telescope scattered across an entire desert. In 2022, astronomer Natasha Hurley-Walker was scanning its data, hunting for things that flicker. Most radio sources blink in milliseconds. Pulsars spin like hyperactive lighthouses, dozens of times a minute. But something in the data pulsed slowly, a flash, then silence, for 22 minutes, exactly. Then another flash, lasting up to 5 minutes. Patient, regular, like the ticking of an impossibly slow clock. They named it GPM 1839-10, 15,000 light-years away, in the constellation Scutum. More telescopes turned toward it. Meerkat in South Africa, Parkes in Australia. The pulses kept coming. Then came the strangest discovery of all. This signal was not new. Astronomers dug through decades of old observations, from telescopes in India and New Mexico. And there it was, in data from 1988, pulsing before the World Wide Web existed. For 35 years it flashed inside our own recordings. No one noticed, because no one thought to look. So what is it? The obvious answer, a neutron star. The collapsed corpse of a giant sun. A city-sized sphere, so dense, a single teaspoon of it outweighs a mountain. Some neutron stars, called magnetars, carry magnetic fields 1 trillion times stronger than Earth's. But physics has a rule. Spin too slowly, and a neutron star must fall silent. Forever. Astronomers call it the death line. Below it, the lighthouse goes dark. No exceptions. GPM 1839-10 sits far below the death line. It should be silent. It refuses. A white dwarf then? Too dim, too slow. No known white dwarf pulses like this. Every model the astronomers tested came back the same way. This object should not be shining. So the question is no longer what it is. The question is what physics we are missing. Maybe it is a magnetar unlike any we have ever seen, suddenly, kept alive by forces we do not understand. Or maybe it is something new. A class of object that has no name yet. And it is not alone. More of these slow, impossible beacons are being found across the galaxy. Whatever they are, they were always there, broadcasting, waiting inside our own recordings. We only found this one because someone finally asked the data a different question. 35 years of pulses, hiding in plain sight. Which makes you wonder. How much of the universe have we already recorded and never once looked at? The sky is full of answers we have not asked the questions for. Next time, a star that has been fading for a century, and no one knows why. If tonight's signal left you with questions, subscribe. This is Kelvin Zero. The universe is cold. We keep watch anyway.